welcome to Notes 6.6. Today we're going to be talking about triangles, their segments, and the proportions that result from them. So we're going to start by talking about the triangle proportionality theorem, and it simply states that if a line is parallel to one side of a triangle and it intersects the other two sides, then it divides the two sides proportionally. Okay, so in this example over here, I have a side that intersects two sides of a triangle, and it is parallel, right, to the third side. Therefore, it divides my two sides of my triangle proportionally. So RT over TQ must equal RU over US, and that's all the triangle proportionality theorem is stating. Very straightforward. So in this example right here, I've got two parallel lines, one of which intersects two sides of my triangle, so it must divide the two sides proportionally, and it wants us to find the length of QU, so that is the thing we are looking for. And I can just set up a proportion. I can just say that 10 over x equals 12 over 6, and you can see that when you solve for x, you're going to get 5. So the length of QU is 5, and that's all the triangle proportionality theorem does. Very straightforward. As you would expect, there is a converse, and the converse simply states that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. All right, we just flip-flopped our triangle proportionality theorem. So if I have a triangle and the two segments of one side are equal to the ratio of the two segments of the other side, then my two segments must be parallel. Okay, so here's a quasi real-world example. I've got a spoiler for a remote-controlled car, and I'm told that AB is 31, and BC is 19, and CD is 27, and DE is 23. So I need to explain why BD is not parallel to AE. Well, if they were parallel, then this would be true. 27 over 23 would be equal to 19 over 31. Clearly, big over small, small over big, I don't even need to run the numbers. Those are not equal, and so I can say, sides not proportional. I can't write today. Sides not proportional, therefore segments not parallel. Okay, very straightforward. All right, now we're going to extend on that, so it doesn't just apply to triangles, it applies to any parallel lines cut by essentially transversals. And so if three parallel lines intersect two transversals, and then they divide the two transversals proportionally. So in this case, because all of these lines are parallel, that means that I could, for example, write a ratio of UW over WY, and it would be equal to VX over XZ. Okay, it divides it proportionally. And that goes on, it's true for more than three parallel lines, right? Any amount of parallel lines, that is going to be true for. I can write ratios, and I can write ratios for parts, I can write ratios for all. Very handy. Okay, and then this one kind of gets lost in the shuffle here, so I'm going to highlight it because this is a very important theorem that people generally tend to just glance right over. If I have a ray and it bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are, oh, there's that word proportional again, proportional to the lengths of the other two sides. So what this is saying is, here I have an angle bisector, and we call this our angle bisector theorem. And if I have an angle bisector, then it divides the end of my triangle into a ratio, right, AD to DB, and the sides of my triangle are going to be proportional to that. So AC, because it's the part that goes with the segment that's on top, goes on top, and then CB is going to go on the bottom. Okay, so let's do a real-world example of the parallel line ones. Standardized tests love this question because you can do it with roads, and you know that they love roads. So I've got a farmer's land divided by a newly constructed interstate, and so we've got the north border of his land, south border of his land, and there's the interstate in the middle. and these are all parallel to each other, and we need to find the missing distance here in order to find the total distance. So we need to find this, but what the question is actually asking for is this whole distance. So we just write a ratio. So 2,000 over x is going to equal 2,500 over 3,000. I need you to find me x, and then I need you to tell me what CA is. Come back when you have your answer. Hit pause now. Okay, you should have gotten that x was 2,400, which means that CA, the total distance from the north border to the south border, was 4,400 meters. Let's do some examples. So in this diagram, I have this angle is congruent to that angle, which means I have my angle bisector theorem going on here. And I need to find the length of DG, which they've helpfully marked with X. And I know that the whole side length is 14. Well, I know that if I have the angle bisector theorem going on, then the ratio of the sides is equal to the ratio of the segments. So I really need to know what this segment is right here. Well, if this is X, then this one right here is going to be 14 minus X. Okay, and if you ever have trouble with that, just give X a number and then find out what GF is and then ask yourself, how did I do that? Well, you did it by subtracting this number from the big number to get this number. Okay, so we're going to write our ratios. So 8 over 12 equals X over 14 minus X. And you are going to cross multiply and solve. Please do that now. Come back when you have an answer. Hit pause. Okay, so DG should be 5.6 or 5 3/5, something along those lines. All right, so now I want you to go ahead and find the answers to all of these questions, and then you're going to actually give me the answer in the notes check, because these are all very straightforward. So I will end these notes here. Very short today, and please be sure to go on and do the notes check, and if you have any questions, ask about them in class tomorrow. Thanks.